So we have finished with the creation and displaying of a matrix. Now we have to write a program for adding two matrices that we have already discussed. So let us write a function for adding two matrices. The function name must be add. It must take two sparse matrices, sparse, and it can take them call by value or call by address. So I'll take them by call by address, though the function is not going to modify those matrices. Sparse pointer S2, two matrices it is taking. Then after adding, it should return a address to a addition matrix. So it will return a pointer to a sparse matrix. Now inside this function, I should also have one more variable for storing the addition of two matrices. So for that, I will take a pointer type object so that it is created inside heap. So first thing is a sparse matrix pointer I have taken. Then first of all, let me create the object of the sparse matrix. So sum assign, using malloc function, I have to create an object. So first of all, struct sparse pointer, then malloc function, size of, we are creating an object of sparse matrix. Yes. Then after creating an object of sparse matrix, I should also create an array for storing the elements. So this pointer, I should assign an array of elements to this one. So after adding total, how many elements may be there? At most, the number of elements will be equal to number of elements in S1 and the number of elements in S2. So for that, I should create an array of elements. So for sum of element should be assigned with an array of type element. So struct element pointer and malloc function, and the number of elements, as I said, it may be at most as at once number of elements plus S2's number of elements, and this should be multiplied with the size of a structure element. So size of struct element. Yes. So this line will create an array of elements for storing all non-zero elements in the summation matrix. Now I should write down the loop for comparing and copying the elements. So for that I require some variables like I, j and k, and I will initialize all of them to 0. I assign, j assign, k assign 0. Now as we have already discussed the procedure for comparing and copying the elements, so simply I will write down the procedure. While I is less than S1's number of non-zero elements and j is less than S2's number of non-zero elements. And while scanning through the matrices, we should compare their row numbers first, that is S1's element of I dot its row number. If it is less than S2's row number, j dot I, that is row number. If this is less, then in sum of element of k, I should copy the element from S1, I, and I should increment both I as well as k. So this k is incremented as well as I is incremented. Now else if S2 is smaller, so I will write on this same code and modify it, these two lines. Now here, in the first condition we wrote if S1's row number is smaller. Here I will just modify this and say if S1's row number is greater. Then in sum of k plus plus, I should copy the element from S2 and this should be j. Yes, these two modifications I have done. And otherwise, if mean row numbers are same, then I should compare column numbers. So whoever column is smaller, I should copy that one. So again, I may require the same type of code but with column number. So I will copy that code and paste it here, and I will modify it for columns. See, here it was comparing row number. So this is J column number now, and this is also J column number. So if S1's column number is smaller, that will be copied. Otherwise, if S1's column number is greater than S2's column number, then S2 element will be copied. Now at last, this final else means both their row numbers and column numbers are matching. If both of them are matching, then in sum of element of K, I will assign the element of first matrix, element of I, then. So when I assign this, row number and column number will be copied. So instead of copying them individually, I am writing the entire element. So row number, column number as well as element will be copied. But element, I will add it. Element of K++ should be assigned with S1's element of I plus plus its X value added with S2's element array of J++ X value. That's it. This will add both the matrices. Now this while loop will continue as long as I is less than S1 matrix and J is less than S2 matrix, and it will terminate when any one of the matrix has finished. So rest is simply I should copy the rest of the elements from the remaining matrix. So remaining matrix may be either the first matrix or the second matrix. So whoever index has not reached their end, I should copy them. So if I is less than S1's number of elements, I should copy all the elements from first matrix. So I'll continue in the same line. Sum of element of K++ will be assigned with S1 element of I. I don't have to increment I because it's already incremented inside for loop. Now the same thing I should do it for second matrix also. So I'll copy this and paste it here, and I will modify it for second matrix. So this is J less than second matrix number of elements and J++. K++ is as it is, and this should be copying from second matrix, and here it should be J. That's it. So this is the code for adding two matrices. And at last, for the sum matrix, I should mention dimension. So its M should be equal to any one of the matrix dimension I can take, that is S1's M, and sum of N should be equal to any one matrix columns I can take, that is same thing. Then this K is having the number of non-zero elements. See, K is tracking the number of elements that we are storing in non-zero elements array. So K gives the number of non-zero elements. So sum of number of non-zero elements, that is num, is equals to K, is assigned with K. So that's all. Now here inside the main function, I will have two matrices. Instead of S, I will take S1, then S2, as well as I will take S3. For S3, I should take a pointer because this add function will add two matrices and returns the address of a sum matrix that will be created in heap. It is creating in heap. So this is returned by address. So here inside the main function, I will create two matrices. First create S1, then create S2. Then we will call add function by passing address of S1 and address of S2. Then the result sent by this add function, we will take it in S3. Then to this display function, I will send all three matrices one by one so that we can see their results at once on the screen. Now before calling display, here I will give a message that printf we are calling showing first matrix. So this is first matrix slash n. Then this should be S1. Likewise, I will print the second matrix, so I will copy this code and paste it here. This is for the second matrix. Then this should be S2. Then after that, I will display sum matrix. New line. Then call display function by sending third matrix. Now third matrix actually is a pointer, so I should send it dereference to value of that one. So it should be called by value. So I should dereference and send it. That's all. Program is ready. We are creating two matrices S1 and S2 and then calling add function for adding them. Then here I am displaying all three matrices, first and second and third. Now let us run the program. Program is running. First it is asking the dimensions of first matrix. So I will give it as 5 by 5. The number of non-zero elements I'll give as 5. Now asking for all the elements. So I will give the elements only in the diagonal. So 0, comma 0 the element is 1, 1, comma 1 the element is 1, 2, comma 2 is also 1, 3, comma 3 is 1, 4, comma 4 is 1. So I have given all values as 1. Now it's asking the dimensions of second matrix. So here also I will give the dimension as 5 cross 5 and the number of non-zero elements I'll give 5 non-zero elements. Now here I will give the elements only in the column, the non-zero elements only in first column. That is 0, comma 0 is 2, 1, 0 is also 2, 2, 0 is also 2, 3, 0 is also 2, 4, 0. All elements I am giving same. Now here you can see that the first matrix is all having all the elements in diagonal. Second matrix is having all the elements in first column. Here the elements are in first column. And the summation matrix, summation of these two matrices, here I got the element 3, that is the sum of 1 and 2, and the rest of the elements are as it is taken from first and the second matrix because there are no common elements. Now let me run the program once again and I will give the matrices as diagonal matrices, both of them as diagonal matrices. I'll do this quickly. Dimension of first matrix is 5 by 5 and the number of non-zero elements are 5. Now the elements are 0, 0, 1, 1, 1, 1, 2, 2 is also 1, 3, 3 is also 1, 4, 4 is also 1. Now dimension of second matrix 5 into 5 and the number of elements are non-zero elements are 5. And now I will enter only the elements in diagonal, that is 5. 1, comma 1 is also 5. 2, comma 2 is also 5. 3, comma 3 is also 5. 4, comma 4 is also 5. First matrix is a diagonal matrix with all 1s and second matrix is a diagonal matrix with all 5s. And the summation matrix, as there are common elements, so they all are added. That's it. So that's all. We have seen the implementation of sparse matrix, that is creation, displaying and also adding two matrices. So practice this program.